All right, so in this video, we're going to be looking at a method called the bisection algorithm, which is a method for estimating the zero of a polynomial that we can't solve for algebraically. Now, we're going to use a cubic example that, in principle, there is a formula for cubics in terms of their coefficients. It's a pretty messy example, but once you get past the fifth degree polynomial, those formulas no longer exist. So this is a method that you can apply to any type of function as long as it's continuous in the interval that you're interested in. It doesn't depend on calculus or algebra. It depends on algebra, but it doesn't depend on calculus or advanced math. And the idea is a relatively simple one. We're going to find an interval on which the function changes sign, and then we're going to keep bisecting that interval in half, and then choose the two endpoints that remain where there's still a change in sign, and we're going to keep essentially closing in on that point of intersection by continually halving the length of our interval until we get to a point where it's close enough that we have a reasonable estimate. So this is a method that you can apply, again, to any continuous function on an interval. If the function is not continuous on the interval, it doesn't apply because the requirement that the function go through zero won't be accurate. Now, the theorem that makes this claim about going through zero is something that is introduced in calculus, but that is a requirement for this. Now, every polynomial out there satisfies this condition. So we're going to look for, I've previously done a graph for this on Desmos, and I've discovered that there is a zero someplace on the interval a positive 2 to 4. Now, if you don't know what the interval is, you can start picking values, plugging them into your function, and making sure that you know where the values are going to end up. So again, you just need two values where one of them is positive in the function and one of them is negative in the function. Now, the way that we can verify this, so I'm going to plug in my two interval values, and then I'm going to evaluate the function. And I'm going to call this x low, x mid, x high, and then f of x low, f of x mid, and f of x high. So I'm going to plug in my two values to start with, not there. And then I'm going to evaluate them into this function. So I have this example function here. So I'm going to take my value here and I'm going to cube it. And then 4 times this value squared plus 3 times this value minus 2. And then I am going to repeat that calculation on the 4, and you can see I'm pointing here at the C column now because, again, the nice thing about Excel is that you can copy these formulas without having to retype them. So there is a sign change. You can see that at 2, the function is -4, and at x equals 4, the function is 10. So somewhere in between these two values, it's going to cross through 0. Now, the bisection algorithm basically says, I'm going to find the average of these two endpoints, so the midpoint of my range, and then I'm going to evaluate the function at that midpoint. And then for the section of the interval where I still have a sign change, then I'm going to make that my new interval. So here I still have a sign change between 3 and 4. So the top half of the interval still has a sign change. So my new low value is going to be my midpoint value from the previous line. and my high value is going to stay the same. Then I'm going to calculate my midpoint again. It's now 3.5. And I'm going to calculate my function at all three of these values. And so now what I see is the 3.5 value is positive and the high value is positive. So I don't have a sign change there. Instead, I have a sign change between the new low and the high and the mid value. So the mid value is going to become my new high value, and the low value is going to stay the same. And so I'm going to calculate my new average, my new midpoint, and then I'm going to calculate my function in both of those places. Grab and drag, there we go. Where do I have a sign change? Between the midpoint value and the high value. So the midpoint becomes the new low, and the high stays the same. And then I calculate my average. And then I calculate my new functions. So these two are both positive. The sign changes in between these two. So the old mid becomes the new high, and the old low stays the low. I calculate my average, and then I calculate my functions. Drag the formula, not the cell values. Okay, so again, I have the same thing happen. So the mid becomes the new high, and the low stays the same, new average. And again, I just keep doing this until I get close enough to 0 for my taste, basically. So right now we're still off by a little more than a tenth. So we need to do a little bit more than what we've got right now. Okay, so these are both negative. So we want to use the midpoint as the new low and the maximum as the new maximum. And Excel will begin to understand what it is you want to do. And so it will start being helpful. Here's my, you notice it filled in what I wanted to do, extending the formulas. My new low stays there. The mid becomes my new high. All right, so now we're starting to get someplace. And I could widen these columns and get more decimal places. I could display these as decimals instead of scientific notation. But when you get really close to 0 within a certain tolerance, then you can say, okay, so that X value is representing my 0. I'm going to make one more step because this is positive, very barely, and this one is still negative. So let's just do one more step. Now these are both negative. So now this one will stay here. This one will be this one. And again, you can see these values are going to keep getting smaller. I want the midpoint here again, the maximum here again. And now we're starting to get, again, really, really close. And we can keep going until we are as close as we would like to be. And in fact, when you're sufficiently satisfied, what you can do is you can even just calculate the midpoint one more time in order to get just a little bit closer to the correct value.